What is a differential calculus? It is basically concerned with determination of rate of change of one quantity with respect to another quantity on which it depends. Say example, if we go for the basic function y is equal to f of x. So in the differential calculus, what we are doing, the rate of, it is concerned with, basically concerned with the rate of determination of rate of change of one quantity with respect to another quantity on which it depends. Means here, as we are changing x value, corresponding change presented in y. So what rate y changes with respect to change of x, that represents, that gives the differential calculus. So we are calculating here the determination of rate of change of y with respect to x. Y depends on x. That is the basic definition. Say example, y is equal to 2x plus 1, just now function considered. And this function is, what we are doing, we are finding its rate of change of y. So y is changing at what rate? As we are changing x value. So that study, that rate of change of y with respect to change of x we calculated, then that is giving a differential calculus. See here, suppose put x equal to say 1. What is y? Y is equal to 2 into 1, 2 plus, this is 3. Okay? And this is x1, this is y1. And say x2, see here. Put x equal to, x1 is equal to 1. Then corresponding y1 is 2 into 1, this is 3. Say x2 is equal to 2, corresponding y2 is equal to 2 to the 4, this is 5. So we calculate how much change presented in y, the rate of change of y with respect to change of x, that is y2 minus y1, the change in y with respect to change in x, that is giving 5 minus 3 by 2 minus 1. This is finally 2 by 1. This is 2. 2 is the amount that, in what way it is changing. So 2 is the amount of value which is the rate of change of y with respect to x. So this is called differential calculus. Means the basic idea to understand, I was given this example, but actually what is happening there, we go through the concept. See here, y is function 2x plus 1. Put x1 is equal to 1, y1 is equal to 3, x2 equal to 2, y2 equal to 5. Therefore, y2 minus y1 by x2 minus x1 is calculation or determination of rate of change of y with respect to x. That is calculated, we are getting 2. 2 is, in this case, rate of change of y is calculated with respect to change of x. That is the meaning. So this is, we can understand by using a suitable example. Okay, leave it. Then go for here. This is our basic function y is equal to f of x. Y is equal to f of x. Put x is equal to x1, corresponding y is equal to y1. Yes, whenever we change x value, so x equal to x1, then corresponding y will also change, say y1. Put x equal to x2, then corresponding y is equal to y2. Okay, so the same function already we discussed, as x changes, corresponding y will also change. Yes, for value of x1, corresponding y is y1, and for value of x2, corresponding y is y2. Now, change of y is how much? y2 minus y1. Change of x, that equal to x2 minus x1. Yes, y2 minus y1 by x2 minus x1 means The change of y is calculated with reference to change of x. So that the change of y is calculated with reference to change of x, which indicates the determination of rate of change of one quantity with respect to another quantity, and on which depends. This is known as differential calculus. Now here the change of y is y2 minus y1. The change of x is x2 minus x1. Then it is as a whole the average rate of change of y. See here, average rate of change of y with respect to x is equal to y2 minus y1 by x2 minus x1. This is average rate of change of y with respect to x. y2 minus y1 by x2 minus x1. We can also write it as delta y by delta x. Delta y by delta x. This is known as average rate of change of y with respect to x. Okay. Now we are taking a limiting case. In this case, this x and y both are giving a finite amount. The gap between x1 and x2. x1 and x2, gap between x1 and x2 giving a finite amount, big amount. Then we are trying to reduce that gap. Means x2 minus x1 is reducing till you get tends to 0. So it is very simple by understanding when we consider the geometric method. By the geometry, we can easily understand this. What exactly here the limit is going to be applied to get what kind of outcome result is giving. So here in the geometry, the same thing, I am going to explain this with a geometry. Suppose a function is given. What kind of function? Y is equal to f of x is a function. So x and y graph is drawn here. Say this is y and this is x. Okay. Now the graph is, say, a function is given. This graph is giving according to this function y is equal to f of x. Okay. Now here this is a chord. This is point A. Here it is x1 comma y1 coordinates. Here this is x2 comma y2. Say it is A. This is A and this is B. A and B is a chord. Now A is x1 comma y1. B is x2 comma y2. Yes, we consider this function y is equal to f of x, which is giving a graph which is drawn between x and y graph. That is along y-axis y, along x-axis x is taken and graph is drawn. That graph is giving a non-linear. Yes, we consider a chord that is intercepting at A and B. This is a chord, right? So the coordinates are giving here. This is x1 and its corresponding. This is y1 and here it is x2 and this is y2. Okay. Now here this is indirectly giving the slope of the chord. See here, this is from here to here, from origin to this point y2 minus y1. This is y2 minus y1, and this part is from here to here x2 minus x1. This part is x2 minus x1. It's very clear. From this right angle triangle, so opposite side y2 minus y1, adjacent side is x2 minus x1. Therefore this is angle theta. Yes, here the slope of the chord AB is a chord. Its slope tan theta. Its slope is tan theta, of course, tan theta, which is giving y2 minus y1 by x2 minus x1. See here, opposite side by distant side, which is giving slope from this triangle. So slope of what? Slope of the chord AB. So indirectly, the average rate of change of y with respect to x, which is giving slope of the chord. Here it is simply delta y by delta x. Delta y by delta x. So this is the slope of the chord. Slope of the chord. Slope of the chord is giving what? Average value. So what we understand over here in the graph. See here. Whenever the x and y values as x changes, y is also changing. We are taking the so many points over this curve. Over this curve, so many points are there. So all these points which are located on this curve, which are included in this chord as a whole average, that start from A and ends at B. And between A and B, so many points which are located, which are taken from this curve, all are included in this chord as average value. That is the average rate of change of y with respect to the x. That is indirectly giving the slope of the chord AB, which is equal to y2 minus y1 by x2 minus x1, which is delta y by delta x. Both are same here. So very clear. By the geometry, what is the inference? So what do you understand from here? So this is average rate of change of y with respect to the x, okay? Then we are interpreted this by taking geometry. And in the geometry, for this function, a graph is drawn and a chord is drawn. A chord is giving two intercepts A and B. At A, x1 comma y1. At B, x2 comma y2. Yes, x1, y1. See here, x1, y1, x2, y2. The corresponding intersection points A and B shown in the diagram. Now, here actually this graph is non-linear, in which so many points which are locating over this curve, but all these points are as a whole including by this chord, which is giving on an average value, that is called slope of the chord, which is including all these points in it, which gives the average value. So that is a slope of the chord, which is giving average rate of change of y with respect to x. Okay, so this is the matter regarding this one, how we can interpret by taking the geometry, right? So next point is, suppose this x2 minus x1 is the big amount, considerable amount. Okay, now I want to reduce this gap. What to do? So x2 is approaching to x1. x2 is slowly approaching to x1. What happens here? This chord is slowly bending down, and finally when x2 is very close to x1, and this chord is slowly bending down, and it is giving a tangent at point A. Now see here, I will explain this clearly. Now this is one more graph. I am reducing this x value. Say this is a curve. Yes, this is initially this is chord A and B. Okay, this is x1 and this is x2. Yeah, x2 is approaching to x1. Whenever it is slowly approaching to x1, then what happens here? Here at point A, whenever it is slowly approaching, see, we can imagine line like this. Yes, it is slowly approaching. Yeah, x2 is decreasing. x2 is approaching to x1, and finally it giving tangent over here. When it is giving tangent at point A, where it is very, very close to x1, x2 is very close to x1, then what happens here? So x2 tends to x1, then which leads to x2 minus x1 tends to 0, then which leads to delta x tends to 0. Means the gap between x1 and x2, it is almost 0. At a very close to 0. Very negligible amount. So this is the limiting case. When we consider this tangent, so what is the slope of the tangent? We can also find the slope of the tangent. See here, slope of the tangent. Slope of the tangent. We are getting by taking the limit condition. So what is the limit? What we are limiting that x2 is approaching to x1, means gap between x1 and x2 big amount, for which we are taking the chord. Chord has its own slope. That slope is giving average rate of change of y with respect to x. Whereas x2 is, we are slowly reducing its value. Whenever it is reducing its value, that is approaches to x1, then whenever x2 approaches to x1 very close to it, this chord is slowly becomes tangent. At point A, it is a tangent to this curve. Whenever it is tangent, at slope can be find the slope of the tangent at A, which is equal to limit delta x tends to 0. Under what condition we are taking this limit? The condition is x2 is very close to x1, therefore x2 minus x1 tends to 0, delta x2 tends to 0. If it is delta x tends to 0, delta y by delta x, this value leads to dy by dx. Here it leads to dy by dx. dy by dx is the slope of tangent. Delta y by delta x is the slope of the chord. Slope of the chord. So what does it mean? Slope of the chord is giving average rate of change of y with respect to x. Now here slope of the tangent is giving, here it is instantaneous rate of change of y with respect to x. It is instantaneous value. This is instantaneous, which is known as differentiation of y with respect to x. This is what exactly the differentiation we can understand by the geometry, by this curve. So here dy by dx is the differentiation of y with respect to x. It is not differentiation. It is average rate of change of y with respect to x. When we are taking that delta x tends to 0, that is limit delta x tends to 0. So limit is applied over average value under these circumstances, then you will get dy by dx. Yeah, dy by dx is the slope of tangent. Slope of the tangent is giving what? Instant. Therefore, it is instantaneous rate of change of y with respect to x. Here it is average rate of change of y with respect to x. That makes a big difference. Okay. Now, what is the need to take the differentiation? The differentiation giving the instantaneous. But here average, it is different. Average value. So if I go for example in physics, suppose when we are traveling by car, that from Karimnagar to Hyderabad, total say it is of say 150 kilometers. 150 kilometers total distance covered. The total time taken say 3 hours. 3 hours. What is the average speed of the car? 50 km per hour. This is the average speed. Average speed of our vehicle. So we travelled by a car. We started from Karimnagar and finally we reached to destination that Hyderabad. Now total distance say it is of 150 kilometers. We took 3 hours to travel. Then what is our average speed of the car? That is 50 km per hour. What does it mean? So here the car is so many speeds maintained as you are in journey. So one time it is covering, its speed is 120 km per hour, other time 150 km per hour, next brakes are applied 0 km per hour, 2 km per hour, and so many different values are there. See here, on this curve we can take so many different values. Okay, so this card from Karimnagar to Hyderabad, A Karimnagar, Hyderabad B. So as a whole, this is giving average. The total distance 150 kilometers and taking time 3 hours and 50 km per hour. It doesn't mean the car continuously moving with 50 km per hour. It is not possible at all. It is not possible. It is on an average. Overall average value is calculated. So which indicates the chord. Okay, suppose somebody will think of that the car has different speeds. Suppose when we are at so and so point, so and so location, suppose at Siddipeta, where the speed is 120 km per hour. That 120 km per hour is the instant, at that instant 120 km per hour. And some other instant you consider that 50 km per hour. And some other instant we consider that 20 km per hour. So we have so many instances where the speeds are different. Therefore, here differentiation helps us to find the instantaneous speed. Means instantaneous rate of change of y with respect to x. But this is chord is giving average rate of change of y with respect to x. This is the big difference between average rate and instantaneous. Means what is our intention? We are shifting from average into instantaneous by taking the help of differentiation concept. Yes, so this is the differentiation of y with respect to x, which gives slope of tangent giving instantaneous. Means on this curve we can make so many tangents. We can make so many tangents. So each tangent will have its own speed at different locations. At different instants, and different speeds are there. To find those speeds, every time we have to reduce this gap and apply the limit. You will get dy by dx, that differentiation of y with respect to x, giving instantaneous value, instantaneous speed. For that purpose, we are using this differential calculus. Yes, we apply to our physics how we can understand this. And one more point, this dy by dx is also known as differential coefficient. We call it as differential coefficient. Yes, in physics how we can apply the same mathematical tool which is taking as application in physics. How we can relate this in physics? Let us see. So in this case, y is interpreted as a distance s. X interpreted as time t. Now, average rate of change of y with respect to the x, we know this. y2 minus y1 by x2 minus x1, which leads to delta y by delta x. Okay. Now this is average value of average rate of change of y with respect to x. Next. So if y is interpreted as s distance, x interpreted as time, therefore average value, average speed can obtain here. Average rate of change of s means y2 is s2, y1 s1, because y is interpreted as distance. So y2 corresponding s2, y1 corresponding value s1 by x2 corresponding t2, x1 corresponding t1, s2 minus s1 by t2 minus t1, which leads to delta s by delta t, and which also taken to be s by t. So total distance travelled by total time taken, which is known as average speed, which is known as average speed. So this is the use and purpose and application in physics, how we can find average speed. Okay, so average speed equal to total displacement by total distance by total time taken, that is delta S by delta T. Okay, come to the point when we go for the graph. Yes, a displacement time graph. So that function is given, that function is drawn like this. So this is the function relating this graph, ST graph, which is giving the curve like this. Okay, this is the curve. So for this curve, a chord is drawn, that is a chord is taken, that giving intersections at A and B. Intersections at A and B. Right? Here at this point on the time axis, that is T1 corresponding S1 distance, and this is S2, and at point B time axis T2, on the time axis its value T2, and this is corresponding value S2. Now see here, from here to here this is S2 minus S1. From here to here it is T2 minus T1. Okay, slope of this chord, slope of the chord. Slope of the chord AB, which gives V. Average slope is Y by X. This is S2 minus S1 by T2 minus T1. So here slope of the chord is giving what? Average value. That average in physics, average speed, because S2 minus S1 by T2 minus T1, which gives S by T simply. Delta S by delta T, which gives S by T. Total distance covered by total time taken, average speed. Okay, now if we apply the limit that time T1 and T2, the gap is big one. Okay, when we reducing this gap, that is T2 is tends to T1, and this chord becomes tangent over here. This is a tangent at point. Now whenever it is converted into tangent at point A, then T2 is very close to T1. T1 and T2 are very close. The gap is very negligible. Therefore T2 is tends to T1, and which leads to T2 minus T1 tends to 0, then delta T tends to 0. Now the tangent giving what? Instantaneous. Therefore we will get instantaneous speed over here. How? When we apply the limit, see, limit delta T tends to 0, delta S by delta T, which leads to ds by dt. So ds by dt, which is giving instantaneous speed. Instantaneous speed. So who gives this instantaneous speed in geometrical way? In the geometrical representation, who gives this instantaneous? Tangent. How you can get a tangent from the chord? When you are slowly moving down this chord, then this T2 is reducing and approaches to T1. So whenever it is very close, and finally this AB chord becomes tangent at point A, where the slope of tangent is giving instantaneous, but here instantaneous speed is obtained, that ds by dt. This is average, this is instantaneous. Yes, slope of the chord is giving average speed, and the slope of the tangent is giving instantaneous speed. Therefore, keep in your mind, wherever you consider the differentiation, definitely it is giving instantaneous speed. Instantaneous velocity or instantaneous speed. Don't think of average. So once you take a differentiation for a function, definitely you will get instantaneous value there. When you are going for differentiation, differential form is always giving instantaneous, and this is chord slope is giving average. So this makes a big difference. So that is the need to discuss the differentiation, because our part is finding the different values in variable acceleration, instantaneous values, and etc. etc. For that purpose, definitely we discuss the calculus part. That is the need of calculus. So it is very important mathematical tool which has wide range of applications in physics. So without using this one, the third part can't be discussed at all. Okay? So this makes big difference. This is instantaneous, this is average. And overall here dy by dx is differentiation of y with respect to x, which is known as differential coefficient. Differential coefficient. It is also known as differential coefficient. Okay? Right. So this is the application in physics.